Ever pondered how artificial intelligence discerns patterns and makes predictions? Could vectors be the key? Welcome to the fascinating realm of artificial intelligence, where mathematical concepts like vectors play a pivotal role in making AI what it is today. Vectors, though simple in concept, hold immense power when applied in the world of AI. For those of us who may not remember, vectors are elements of a space possessing both magnitude and direction. Imagine an arrow pointing from one point to another. That's a vector. But how does this simple concept become such a crucial part of AI? Imagine a vast sea of data. To navigate through it, we need direction, and that's where vectors come in. They help in defining the direction of the data flow, enabling AI to make sense of this sea of information. Vectors are also instrumental in representing data. Think of each data point as a vector in a multi-dimensional space. This representation allows AI algorithms to perform complex calculations, discern patterns, and make accurate predictions. Moreover, vector operations form the backbone of many AI algorithms. Vector addition, subtraction, scalar multiplication, dot product, and cross product are all fundamental operations that allow AI to process and interpret data. Additionally, the geometric interpretation of vectors provides a visually intuitive way to understand these operations. It's like a map that guides AI in the right direction. By visualizing data as vectors in a geometric space, we can understand the relationships between different data points, which is crucial for many AI applications. In the next few scenes, we will delve deeper into these concepts. We'll explore the definition of vectors, how vector operations are performed, and how they are geometrically interpreted. Intrigued? Well, you should be. Let's dive into the world of vectors. To embark on this journey, we need to first understand what vectors are. So, what exactly is a vector? In the simplest of terms, a vector is a mathematical object that possesses both magnitude and direction. It's a fancy way of saying it's something that has size and points somewhere. But don't be fooled by its simplicity. Vectors are fundamental to many areas of mathematics and physics, and yes, they play a crucial role in artificial intelligence too. Think of magnitude as the length or size of the vector, and direction as the way it's pointing. For example, if you're driving a car, your speed would be the magnitude, and the road you're on represents the direction. Vectors are typically represented as arrows, with their length indicative of their magnitude and their pointed end showing the direction. However, in mathematics and AI, we often represent vectors as a list of numbers in brackets known as a vector space. Each number in this list represents a coordinate in a dimensional space. A vector with 2 numbers represents a point in 2-dimensional space, while a vector with 3 numbers represents a point in 3-dimensional space, and so on. Now, why are vectors so important in AI? Well, they're a way of capturing numerical information about things in a way that machines or AI can understand and process. For example, in machine learning, vectors can be used to represent a variety of data points like the features of an image or the words in a text document. One of the beautiful things about vectors is that they can be added, subtracted, and multiplied in a multitude of ways to create new vectors. This ability to manipulate vectors is key to many algorithms in AI. So, in essence, vectors are a fundamental mathematical tool that allow us to capture reality in a form that AI can understand and work with. They are the language that computers and AI algorithms speak. Now that we've demystified vectors, we can delve into their operations. Vector operations are more than just simple math. They're the building blocks of complex AI algorithms. Let's dive into one of the most fundamental vector operations, addition and subtraction. At first glance, these operations might seem straightforward, but their implications in the world of artificial intelligence are profound. In essence, vector addition is about combining. If you have a vector moving you 3 steps forward and another urging you 2 steps to the right, adding them results in a single vector that encapsulates that combined movement. It's like having a concise summary of your total motion. Vector subtraction, on the other hand, is about finding differences. If you subtract a vector that points 2 steps to the left from the one that moves you 3 steps forward, you'll end up with a vector that represents the difference in these movements. It's like pinpointing the gap between where you are and where you want to be. Now you might wonder, where does all this play into AI? Well, vector addition and subtraction are at the heart of many AI processes. Think about a recommendation algorithm. It uses vector addition to combine user preferences and subtracts them from the characteristics of available items to find the closest match. Or consider an AI that's navigating a complex environment. It adds and subtracts vectors to calculate the shortest path to its destination. It's like a digital compass guiding the AI through a sea of data. And let's not forget about machine learning. Here, vectors represent features of a data point, and their addition and subtraction help in making predictions, classifying data, and so much more. So, as you can see, vector addition and subtraction might seem like basic math, but when applied to artificial intelligence, they become powerful tools. They help algorithms understand, navigate, and make sense of the complex, multidimensional spaces they operate in. So, addition and subtraction of vectors isn't rocket science, but it's definitely AI science. Multiplying a vector by a scalar is like giving it a power boost. Let's see how. Scalar multiplication is an operation where every entry of a vector is multiplied by a scalar, a single real number. Imagine a vector as a car, and the scalar as the fuel. The more fuel you add, the further the car goes. Similarly, when we multiply a vector by a scalar, we're essentially scaling its magnitude without changing its direction. In the context of artificial intelligence, scalar multiplication is essential. It's used in algorithms to adjust the weights of inputs, aiding in the refinement of AI models. Think of it as a control knob, fine-tuning how much importance each input should have in the final computation. Moreover, scalar multiplication plays a key role in gradient descent, an optimization algorithm that helps AI models learn more efficiently. By scaling the rate of descent, it ensures the model doesn't overshoot the optimal solution. Scalar multiplication, a simple yet powerful operation, plays a pivotal role in scaling AI computations. Dot product and cross product, two vector operations with a monumental impact on AI. Let's dive into the fascinating world of these vector operations to understand their role and significance in AI. First, let's talk about the dot product, also known as the scalar product. It's a binary operation that takes two vectors and returns a scalar. The dot product measures how much of one vector goes in the direction of another. That's why it's often used in AI to calculate the similarity between vectors. It's like asking, "Hey, vector A, how similar are you to vector B?" The dot product gives us the answer in the form of a scalar. Now, let's move on to the cross product, or the vector product. This operation takes two vectors and returns another vector. The cross product measures the area spanned by two vectors in three-dimensional space. The result is a vector that is perpendicular to the plane containing the original vectors. In AI, this operation helps to determine the orientation of vectors and find orthogonal vectors, which are crucial for computations in three-dimensional space. You might wonder, why are these operations so important in AI? Well, the dot product's ability to measure similarity is fundamental in many AI applications. Think about recommendation systems. They rely on the dot product to find similarities between user preferences. And what about neural networks? They use dot products to calculate weighted sums of inputs. On the other hand, the cross product is essential in robotics and computer graphics, areas of AI where spatial relationships need to be understood and manipulated. The cross product allows robots to understand their environment in three dimensions and helps create realistic animations by calculating the orientation of surfaces. So there you have it, dot product and cross product, two powerful operations that help AI see, understand, and interact with the world. They might seem like simple mathematical concepts, but without them, AI would be like a ship without a compass, lost in the vast ocean of data. Dot and cross products are the hidden heroes behind AI's pattern recognition capabilities. Now let's take a visual journey into vectors and their geometric interpretation. Imagine a world where lines and arrows become a universal language, where direction and length are more than just coordinates or measurements. Welcome to the world of vectors. In this world, each vector is a directed line segment represented by an arrow. But how does this relate to artificial intelligence? Think of a vector as a way to capture both magnitude and direction. The length of the arrow represents the magnitude or size, while the direction of the arrow indicates, well, direction. If we think of these vectors as inputs in an AI system, we can start to see how they can influence the output. Take a self-driving car, for example. The car needs to know the direction and distance to the next turn. These two pieces of information can be represented as a vector. The AI system uses this vector to calculate the car's next move. Now, consider a vector in a two-dimensional space. It's like an arrow floating around on a flat plane. The tail of the arrow is at the origin of the coordinate system, and the head of the arrow points to the coordinates of the vector. Simple, right? But what if we add another dimension? A three-dimensional vector isn't that much different. It's still an arrow, but now it's floating in space instead of a flat plane. The tail is still at the origin, but now the head of the arrow can point anywhere in space. This is where it gets really exciting for AI. With more dimensions, we can represent more complex data. Think of a vector as an instruction for a journey. Starting from the origin, the vector tells you how far and in what direction to travel. In AI, these journeys can represent anything from the path of a self-driving car to the trajectory of a robot arm to the learning path of a neural network. Visualizing vectors geometrically truly brings to life the magic of AI. We've traversed the fascinating world of vectors and their operations. Let's recap. We began our journey by exploring the definition of vectors, these magical entities that have both magnitude and direction. We then moved on to vector addition and subtraction, understanding how these operations help us navigate the multi-dimensional spaces of artificial intelligence. Next, we delved into scalar multiplication, a process that scales our vectors, impacting their magnitude without altering their direction. Our exploration then took us to the dot product and cross product, two powerful operations that give us insight into the relationship between vectors. Finally, we soaked in the geometric interpretation of vectors, appreciating the beauty of these abstract concepts made tangible in the real world. So we now understand how vectors and their operations form the backbone of many AI systems. Next time you marvel at AI, remember the humble vectors playing their part behind the scenes.